Hi everyone, welcome to this new video. Today we're going to talk about SQL. This is a review of the structured query language. So SQL it was invented in the 1970s, so more than 50 years, and still is very active. You will see like in companies all over the world they are using SQL on a daily basis. It's not going anywhere. For sure, if you are working on data science or related fields, SQL has to be in your toolkit. Okay, so the reason of this video is because even though we're working in a big data class, so a lot of times we have said, okay, we need to move from SQL to a different format to non-SQL, but in order to do so, we need to understand a little some basics to have an idea of SQL in case you haven't used it before. I'm pretty sure that most of you have used SQL at the professional level or even in previous classes, but just in case, this is a review to explore the basic codes. Okay, so here we have we have databases. The whole purpose of this database is to store, manage, and retrieve data. One type of database it's SQL, the structured query language, and on the other hand we have NoSQL. So it's important to say that NoSQL means not only SQL, right? So that includes tables and non-structured data. Okay, so this is a declarative language. What is the meaning of declarative language? It means that when you're using SQL, in your queries, you just say, okay, I want to do this, I want to select this information from this table, but you don't have to specify how. SQL will do it for you. So that's interesting. That means that it's simple in general. So once you know the basic commands, SQL will do the rest. Alright, so some key concepts. Of course, in the world of relational data, you need tables. So when you're working with SQL, there will be multiple tables, and each table will have rows and columns. And for each table, there is typically at least one primary key. So that's the way in which we connect tables. This has to be a unique like variable that it's able to connect with other tables. So it is important to know the primary key or foreign keys. Again, to establish relationship between tables. There are different data types. The typical data types will be like integer numbers, strings, dates, and you know, like the popular and basic formats that you have seen before. So there are multiple commands in SQL. Maybe some of them. It's create when you want to create new tables. You can insert new information. You can delete. You can update information. Select, really popular when you want to visualize or you want to choose like which columns you want to see. Aggregate functions, these are really important when you are doing some computations. So when you want to count, when you want to sum or find the average, max, or minimum value. So these are like statistics, right? Some metrics to perform some EDA, exploratory data analysis. We also have group by, which is useful when you want to compute some of these metrics, but based on a variable. For example, you want to compute let's say, what is the sum of the sales per region. So if there are 5 regions, you want that the transactions for each region is going to be summed separately. So you want to add up only the transactions for one of those regions separately. So the group by is going to ensure that when you are doing the metric, when you are finding the metric, you will do it, you know, with the transactions of the same region. Having is a way to filter aggregated data. Order by is when you want to sort your information like from based on a variable, like you want to sort it from the maximum value to the minimum value. So you use the order by. If you want to filter data, so we have where, and we have the typical operators such as and, or, between. And these functions are really important because, as we said earlier, here typically in SQL environment you will have multiple tables and they are related to each other. So when you are trying to get some information, you need to join the tables. You need to combine some of the tables. So that this is how we get the inner join, left join, right join, full join. So there are multiple ways to put together our tables in order to answer some business questions. Okay, so let's continue with the operations. We can insert to add new data into a table, select to query data from the table, that's if you want to read, update to modify existing data, delete. So here is an example. So the question is, display all employees from the sales department. So here we have the first command is select. Then you need to specify which columns you want to see. So here that we're using an asterisk or a star, it means that all the columns. So we're going to pick all the columns. If you want to select only some of the columns, then you need to specify the names of those columns. From, that means like from which table you're going to get that information. In this case, there is a table which the name is employees. But remember that we want to see the employees only from the sales department. There are departments in your database. So you need to specify that condition. So we're going to select all the information from the table employees where the variable department, so that has to be a field in the table employees, it has to be equal to sales. So at the end, that query is going to return a table with the name of the employees that are working in sales. The joins is to combine tables in order to get some information in order to compute some metrics or statistics. So we might have inner join, it's going to retrieve only the matching records, or a left join, right join, full join. So that will change like which records are going to be retrieved from the left or from the right. So for example, in the left join, it retrieves all the records from the left table plus match ones from the right. Let's see example here. Display the employee's name and their department. So here we have two tables, one for the employees and a different one for the department. Okay, so the query starts with, let's select from the table employees dot name. That means that we're going to pick the variable, the column name from this table, from employees. And we also want to see the department name, but that one is in a different table. The name of the table is departments. So we have two tables here, employees and departments. So we want to see the name and department name from employees. But remember, there is not just one table here. We need to retrieve information from two tables. So we need a join. So we perform the join here. So employees and departments on. That means like, okay, using which variables we're gonna do the join. So the key variable here, it's department ID, debt ID, and department's ID. So that means that in the table employees, there is a column or a field with the name debt ID. Now in the departments table, there is one. In the departments table, there is one field or variable with the name ID, right? So when you do the join based on these two keys, then at the end we will be able to get our desired result, which is a table with the name of the employees and the department name. Again, here it was required a join to be able to get information from these two tables. The aggregation, we will do some examples at the end. The aggregations, so here we have the metrics, the sum, count, the average, max, mean, that they are like the popular metrics. The group by is really important to do the aggregations, because again, based on a variable, it's going to group the observations to apply the desired operation. Having is to filter our aggregated data. So let's see an example here. Find the departments with an average salary, so we need to compute the average salary, greater than 50,000, because that's per year. So we want to pick, okay, we want to select department, right? And then here, please notice that we're computing something. This is not in the table, right? This variable does not exist. The field does not exist. So we're creating a new variable, which is a metric, the average salary. It's possible to assign like an alias. You can do that if you want. Like change the name. So instead of getting like AVG salary, you can get like a different label or text for the name of the column. Alright, so we want to get this to department and average salary from the table employees. Now, for the average salary, it's important to group our information, because if we don't have the group by here, if we just apply the average salary, it will compute the average salary for the whole table, and that's not what you want. What you want here is like, we need to find the average salary for the department sales. You want the average salary for the department HR. You want the average salary for the department production, for example. So in order to do so, you need to group your information. So we group by department. Group by department means that now the average salary is going to be computed only based on those observations that share the same department. So up to this point, we have the average salaries for the departments, which is fine, but now remember the question is asking to get only the average salaries that are greater than 50,000. So once we have computed the average, now we can filter, so the aggregated data that we have, so we say, okay, having the average salary greater than 50,000, and then we will be able to comply with the question. Okay, there are limitations, of course, for SQL, and that's why we're studying SQL to move to the next step, which is NoSQL. So it has a release schema. So if the data structure changes, then that will create a mess basically in your existing relational database. The scaling part, relational databases, they increase vertically, so they need larger servers, and that's expensive. So it's vertically scalable, it's not horizontally scalable. So handling unstructured data, SQL is not good for that. SQL is optimized for structured data, tables, but if we have a semi-structured or unstructured data like documents, images, text, then we will need JSON file, for example. So if we have something like this, like JSON, where you can have like nested values inside the table, then SQL is not a great deal, right? So we'll transition to NoSQL in the next videos. So remember, NoSQL is not only SQL. So these are non-relational databases that are more general. So they are designed for unstructured and semi-structured data. Now, why NoSQL? Basically because they have a flexible schema, so data models can evolve. The horizontal scalability, remember that SQL has vertical scalability. So horizontal scalability is desired when you have big data. And again, because we can handle unstructured data, files like JSON or XML. All right, let's go to solve some examples, and let me show you how to set a SQL programming language in Colab. So first, let me give you some context of the thing that we're going to do here. We're going to work with a database, and that database has 11 tables. So these tables, they are connected. So this is the diagram that shows you the relationship between the tables. So this information is about a music store. So they sell, like music in different formats. So what information we have? We have customers information, the invoices, the tracks, we have the artist information, right? Albums, and the employees of the store. So we have, like different type of tables here, and everything is related to a music store. Here there is an explanation of each table. This database is called the Chinook database. You will find it online. It's a common example. All right, so before we move forward to answer some specific question, let's ensure that a Colab is going to be able to handle SQL. So first, we need to install two packages. So if you're using like a very standard package, for example, pandas in R in Python, or tidyverse in R, most likely Colab you won't need to install it. You just need to call the library, and that's it. But in the case of the packages that I'm going to use, we'll need to install them. So to install them is pip install SQL Alchemy is the first one, and the second one pip install IPython SQL. These are not the only packages for SQL, there are other options. So you can explore them if you want, it's up to you. I think with these two, the SQL part of the queries is simple. That's my opinion, but again, there are other alternatives. That's common in programming, there is not only one way to solve a problem. Alright, so let me install the packages. So while everything loads, let's activate the SQL commands. So that's percentage let's load the extension SQL. Alright, now we need to upload our database. There are several options here. You can upload the file here, or you can kind of like save the file in Google Drive, and you can connect your Google Drive to notebook to this notebook. So maybe it's easier, it's more flexible, but that's up to you. So in this case, I'm gonna just upload the file, the Shynook file. This one is gonna be in Brightspace. I'm gonna ensure that it's available for you. If you, you will find it over there, but in general, also if you Google it, you will find it for sure. Even generative AI like ChatGPT, if you talk about Shynook, it will understand, because it's a popular database. Okay, please notice that extension is .db. So this one contains the 11 tables. Okay, so let's import our database. So I need to specify that this is SQL. SQLite. So it is in content Shynook.db. If you don't know it, it's simple. You just go here and you can copy the path. You can copy the path and you just paste it. And that's it. It's just like 4 slashes and then the path. And that's gonna be it. So we import, so it's ready. So now we uploaded information. So our Colab is ready to explore this database using SQL. It's simple, and there are some easy steps. It's just we installed two packages, then we enable the extension SQL, and the last step was just to upload the file and load the database. So once it is available, now let's answer some questions. Okay. So these are simple questions. The idea is just to get you started in case you haven't used it before. Again, I believe that most of you are familiar with SQL. I'm gonna maybe ask you in a poll, because if you need me to kind of like go deeper in SQL, I think it's useful. Even though it's not the purpose of our course. For sure, you need to know SQL in order to move forward to more complex structures. Okay. So let's go with the first one. Retrieve the list of all customers and their respective countries. So that information is in the table customers, and we want to get information about the country and our customers. Okay, since I'm going to write SQL, so in every cell I need first to do the percentage SQL, and please notice that the color changes. And now I will start with select. I want to see a first name. Let me show you something before I do this, because in general you don't know the fields, right, or the columns. So one thing that you can do for the table is just select everything, the star, from customers. So we close the statement, and it will show you the table, the complete table. So now you can see the different fields. So this is first name. So we want to see first name, we want to see last name, and the country, right? That's the question. So we need to select these three specific columns. You can also limit this is just an option, you can just limit, if you want, the number of rows, maybe just to see the first 10 customers. If the table is too big, maybe that's a great idea. Alright, so instead of selecting everything, I want to select first name, last name, and we said the country, right? If you want, you can have like multiple rows, that's not a problem at all. And now you have the information. So we have our customers, the first 10 customers. If you want to limit, if you want to see the whole table, just erase this, and that's fine. Just remove the limit, and you will see the complete table. So that's the desired information, right? Okay, now we have one more question here. Is find all customers located in Brazil. So we want to select customers, and we want to filter based on the country variable. So we can use the previous one. I'm gonna copy. Let me show you what happens if you don't add the percentage SQL. Please notice that select from these are commands, like commands and codes from SQL codes, and they are not in blue, right? They are just like any other text. So that means that it's not recognizing that they are SQL. That's why we need to add the percentage SQL. And now you see the color changes. It means like, okay, that's SQL, right? It's recognizing the codes. So we're gonna see first name, last name, country from customers, but there is a condition where the country is equal to Brazil. So we filter. Let me show you, there is an error here. Let me show it to you. Even though we need to add, it worked, but we didn't add the semicolon here. The package was good at reading this, but you need to add the in SQL. Alright, so we have the first and last name and the country. But again, this is only for the observations or the customers with country equal to Brazil. Okay, let me see, because I just read a message that I got disconnected. I want to confirm that it's working. Okay, it's working. Now we will move to our next question. We want to analyze a different table, invoices. So first, let's visualize that table. So let's do the percentage SQL, and we want to select everything. If you notice, I'm getting here the suggestion for the right code because I'm practicing, like I have this file, the file exists, there is a notebook with the solution. That's why here the AI is suggesting me to just like tap and get the code. I'm gonna type it. just to match your speed while you're watching the video. So we want to select everything from invoices, and we can limit to 10. That's optional. And here we see information: the invoice ID, customer ID, there is a date, billing address, the billing city, billing state, billing country, and we have the total, the value. Okay, then there is a question related to the table, to the invoices table. It says find the total sales for each country using table invoices. All right. So we need to do some matrix here, aggregated matrix. Okay. So let's select we want to see, remember, the sales per country, right? So billing country is the name of the country, that's the variable. With that information, we need to sum the information. We need to sum the information. So we want to sum, and the variable here is total. That's the last column, right? So we want to sum the total of the transactions. If you want, so instead of getting the sum total in the label, you can specify an alias for this. You can say, you know, I want to see this variable or this metric as total sales. This is optional. So far what we're doing is we're going to select, we want to visualize billing country, the sum of total as total sales, right? We need to specify from which table, right? From invoices. And there is one more thing. If we leave it like that, it will sum everything. You know, it will sum the total for every single transaction. Because we haven't specified that we want to sum the total for observations that belong to the same country, transactions that belong to the same country. So we need to group. We need to group our transactions using the billing country, because when we do that, when we sum a variable like the total, it will sum the total, but just for the observations that belong to the same country. So let's group by the billing country. Again, I'm typing everything, even it's suggested, just to match your speed. Because otherwise I will just give you the code, but I think it's better if we go step by step. Alright? So now we're getting the countries, right? With the total sales. Now this is optional. If you notice, they are in alphabetical order, like A first, then B, C. But if you want, we can rearrange everything. We can order by total sales in a descending way, from the maximum value of total sales to the minimum value. So let's do that, just to show you. So it's ordered by total sales in a descending way. So we get the same result, but now we have the maximum value of the total sales first. That's in the US, in the US. Then with Canada, France, Brazil, and you can keep doing the analysis here. All right. Let's keep solving more questions, answering more questions. So now the question is, find the top 5 artists by the number of albums. So let's do SQL. So we're gonna get the name of the artist and the number of albums, right? That's the idea. but the information is not in the same table. So there are two key tables here. One is artists with the artist information, and the other one is albums. So at the end we want to see artists. I'm gonna use an alias here. So this is for artist, AR, name as artist, just artist. Then we want to count on the albums table. I'm going to use an alias AL, just like that. And the variable that we want to count is the album ID. It's just to count how many albums for that specific artist. Album ID as is going to be album count. So from artist, and I need to specify the alias, the AR, right? Because we're using here r.name. Again, if you don't want to use the AR, that's fine. You can just type here artist.name, and that's it. Artist.name, and here from artist, and you don't need the alias here. If you want to use the alias, that's fine. You define it here, and it should work. Okay, but here we need to perform a join, because we're using information from two tables. So we need to join the tables before answering the question. So let's join albums, and I need to define the alias that we're using, all albums on. Now I need to specify the keys. That means like what are the two variables, one from artist table and the other one from albums table, that I want the join to match. So the join is going to be performed based on these two columns. And they are supposed to be the same. So the artist ID, that's the name of the variable, is to be equal to the all artist ID. So the name of the variable is the same. The difference is like one is located in the artists table and the other one is in the albums table, right? That's the key to perform the match. So once we have combined the tables, so we want to count the albums, right? But if we count the albums, we will we will add up we will count all the albums. We need to ensure that we count per artist. So we need to group our information. So let's group by the artist name, so we can perform our operation. There are so many artists here, so we can limit only to the first 20 artists. And you can, of course, you can rearrange this. You can sort the observations in your output if that's what you want. Okay, so here we are getting how many albums or the album count per artist. Let's do the order by. Order by the variable album count. That's how we call it. And in this descending order. So we get, like the first artist here with more albums in the music store. It's Iron Maiden, 21 albums, Led Zeppelin, 14, and it's decreasing the name of the albums here. And the last question is related to the previous one, is just find the artist with more than 10 albums. We can see that here, there are 3. Let's say that we wanna, use a code to do that. So I'm just gonna copy. Yeah, I'm gonna copy the information here, the previous code. Oh no, the same question 4, this one. I'm gonna copy this. So find the artist with more than 10 albums. So we need the same information. We want to select the artist name. We want to count the albums from the artist with the alias AR, and we're joining this table, the artist table, with the albums table, which we're assigning an alias AL on these other two keys. This is how I'm gonna perform the join. So the artist ID, it's in artist table, and the artist ID, same name, it's in the albums table. So if they're equal, the rows are going to be joined. You know, we're grouping based on the artist name, and we're ordering in a descending way, right? But before we finish here, remember that the question is, okay, artists with more than 10 albums. So once we find we do the counting. So we need to add a having. This is a filter for aggregated data. So having album count greater than 10. So once we apply this filter, so it will give us the output is going to be only those artists with 11 or more albums. So there are three artists. All right. So with this we have covered the basics of SQL, at least some of the commands. We have solved some easy examples. In the homework of this week, I'm gonna add more problems, like maybe more challenging problems. And again, here you have like a lot of technologies that will help you to solve these problems. Remember, you can use generative AI, but it's important that you understand what you're doing. So I know that you will be able to solve the homework easily, but what I really want you is to understand the codes and to be able to replicate it. That's the important part here. Okay, I'm going to stop the video. I'll see you in our next session.